Welcome back to the Old Iron Lever channel. My name is Bob and we're off on another project today. This is one I've been wanting to do for a long time. I have a 30-ton hydraulic press, and it's about all it doesn't need to be any heavier, although I did design it so the table has minimum deflection at 50 tons. The problem when I built it was that I didn't realize how heavy a 50-ton jack was, and I couldn't get it up in there by myself, so a 30 I could barely handle. I got it up there. That's when I was younger. Anyway, I've used this press for years. It works wonderfully, and it's been able to break anything I put in it. So one of the things I do with it is I bend things. Now I have bent sheet metal in it with this stuff I'm going to show you here, but more I use it for brackets and that kind of thing. So I think the most recent video I did before this one was about the rear window storage for my load bar and my snow brush, my big long snow brush, and I used those set up for the bending brake on that. Here's a couple of them I made. This is one of the first ones I made, and it worked. It's kind of small, but it does what I wanted to do. Most of the things I bend are like maybe an inch wide or inch and a half wide, and 1/8 inch thick. I have bent 3/8 inch steel with it, and it works. I lost this one, and I decided I'll make another one, and so I made this one a little heavier, a little bigger. They both suffer from the same problem. There's no way to set things up in it. You're fiddling around with trying to get the piece you're going to bend in there, and get so you're going to bend a strap. You lay it across here. You want to get it square. You want to get this lined up with straight up and down, and you want to get it underneath the press at the same time. All you have to do is bump something, and you get a kind of a crooked bend, and it's not taking a full advantage of the width of the table. And also, when the press comes down on it to push on it, if you have a longer piece, as it bends, it'll fold up and it'll run into the bottom of the plate that's got the jack on it. And I want to kind of get away from that. So this one's going to have some new design features. But we're going to start out. So now that you see what's going on, I want to show you what we're going to go ahead and make a new one, and this one's going to have all the features in it that I think I'll ever need. It'll be the full width of the table. It will be upside down from these, so this will be on the bottom, and that way when I'm bending something, it'll be set up so the ends won't run into anything and cause a problem with the bend. And it will be on a frame that's got some guide rods on it that will keep these things in alignment, and it'll have, if everything goes right, there'll be a set of springs that will hold it open until I get my piece in and I can get everything exactly the way I want it and run the jack down. It should greatly simplify that. So I decided to make it as permanent as I could. So it's going to be made, these pieces here, this and the corresponding V-notch one, and the rods are all going to be 4140 steel. And I may or may not harden it, but at least I have the possibility. And it's going to be quite a bit beefier than what I did have before. So first project is to cut off a couple of pieces of the appropriate length, one of them for this piece and one of them for this piece. And they're made out of the same steel, and they're going to look something like that, only bigger. Okay, now we're going to address the problem of cutting a 45-degree angle on here. Now, this isn't a critical measurement. I'd like it to be pretty close, but I built this jig a long time ago, and it has a couple of angle iron, or not angle iron, but welded up pieces here to hold it at 45 degrees. I also have another pair that'll hold it at 30 degrees, or 60, whatever. Anyway, how do I determine that my cutter is going to make an even pass across this corner? Well, I got to make sure it's not tipped this way, and make sure it's not tipped this way. So putting a V-block on top of it, and I've got everything ready to go here. Well, it's surprisingly accurate. It's 3/1000 lower on this end than that end. That's not too bad. Now, what I can do is take this apart and slide a 3/1000 shim underneath it. And I'm kind of deciding whether I really think it's that important. Let's see how. I'm more concerned it's going to be off this way, but worst case is I'll put a 3/1000 shim under it and get that squared away. Now I'm going to re-rig all this and put the dial indicator on the side. And we're going to do the same exercise, go in the other direction. So, try to keep my arm out of the picture here. That ought to work. Well, so far I hadn't moved, but the handle's going to hit the tripod. Here we go again. I'm amazed. It's basically dead on. Well, the way I set it up is I put a block in here, or actually a T-square in here against this edge, and set it, exactly the same distance from here to here as from here to here. So I think we're in pretty good shape. I kind of hate to even mess with the setup for 3/1000 on the end. I think I'm going to leave it alone. But at least I'm confident now I'm not going to come up with something that's all crazy crooked. Okay, I'm set up to make the cut here. I've got my DRO Z-axis set at 0. The depth of cut from the geometry is 1.078. But I'm going to leave it a little short, so I'll have a little bit of a flat on top of the V, and that'll give me some material to kind of round it a little bit, so I don't have a sharp bend right in there. So let's take a 40/1000 cut. Okay, that worked pretty good, and I'm just going to go back and forth with the cuts. So take another 40 thousandths. Okay, we should be 30 thousandths from the edge of this cut now, and we'll start at 40 thousandths after we've touched off. See what that looks like. Well, off camera, I got the vise trammed in, got this cranked down good on it, and ends are lined up flush, and I've got it clamped down, and 0, 0 is my little punch mark there, which I marked earlier just for sanity check. Now we're going to spot drill it and then start drilling. We want to wind up with a 1/2 inch, just a hair over 1/2 inch hole. Okay, we got 31/30 seconds next. Okay, we're going to reamer, leave this as a 1/2 thousandth over. Well, the next step is going to be to prepare the rods that the top and bottom will slide together on, the guide rods. I'm going to use a 1/4 inch 20 socket head cap screws in there. So we're going to take, center drill this and then take a number 7 drill and go in deep enough that I can get the screw in pretty far. Not that it's going to make a big difference, there's not a lot of pressure on this. Let's turn on Okay, the next piece of the project is going to be to take the ends of these, which will be not really used for bending, and trim them down to where they're flat across here, so we get rid of the top of this V. Back 1 3/4 inches on both ends, and the same thing with the male portion of it. The idea is we're going to have these two pieces together with a spring in between. I want a flat surface for the spring to rest on, and I want to take away some of the height so we have enough room for the spring to compress without collapsing the spring entirely. So we're going to take our little 2-inch mill here, touch off here, dial in 1 3/4 inches, and we just go back and forth with it many times until we've taken out the bottom of this groove. Hope that makes sense, and I think we're off and running here. Okay, we've got this down to right on 1/2 inch, and I'm going to make all the ears, all 4 of them, 1/2 inch thick. That's plenty, and it gives me plenty of room for the spring to exist in the compressed state. So, not boring you with all the rest of these. All right, we're getting ready to start on the next one. This is the male version of the previous one. Take it down till it's 1/2 inch thick also. Okay, I'm getting ready to do some counter bores, and when I'm using socket head cap screws, that's what you need to use to recess them into the work. Anyway, I have set this counter bore down on top of the piece I'm going to work on. The pilot fits neatly inside the hole, and I'm going to come up 1/4 inch, which is the recommended counter bore depth for a 1/4 inch bolt. And now you'll find that commonly a 1/2 inch bolt will have a 1/2 inch counter bore depth, and the diameter of the counter bore is basically slightly bigger than the head of the socket head cap screw. So anyway, this one's 1/4 inch. We're going to just do a quick boring here. And you can see here that the counter bore fits very nicely. Okay, getting set up to put a little flat on here to go. So you use a wrench while we're tightening up the screw that holds it onto the base plate. Well, there's the finished product. Thought I'd give it a test run here. First thing, I got a piece of, I think this is 10 gauge. Let's see if first of all will it fit down my groove there. No, it won't fit. Now it's a little wide. It's intended to be used in this position with this outward V on the bottom, so that the long pieces can push down in here between the two parts of the table. But I just want to see how well it actually bends this. And I've got this lined up pretty well. So I'm only going to be able to bend it to a short distance, but once it starts bending, it should be fine. Actually, I may be able to fit that in there. Okay, here we go. And it put a bend in it. Not sure if we were dragging on the sides of the press or not, but I think that's a piece of 10 gauge scrap. So let's try something a little more challenging. Here's a piece of 3/8. It's not ideal, but because it's got a hole in it, but now that's too thick to really make a good bend because the shallowness of the, well, it might be okay. I think it's actually going to be fine. I usually don't bend anything at 3/8, but I wanted to make sure, since it's my forever tool, that it's going to handle it. And there you have it. So I'm very pleased with it. I think that'll do any old job I want to do. And of course it's some fairly heavy 4140 steel, and it really doesn't bother it at all. Well, as always, thanks for watching, and hope you enjoyed it. That press ought to last me the rest of my life. There's one of the earlier ones I built. I had no way of keeping everything straight in it or any of that, and it was pretty small. I stepped up and built a bigger one, and same drawbacks, as with no real way to keep it straight. One of those, I think the little one, I misplaced this piece and had to make another one temporarily. So anyway, they're all going to go somewhere else, and they're all just mild steel. So anyway, if you like the video, give it a thumbs up. If you like the channel, well, please subscribe. I'd love to have new subscribers. And if you have a comment to make you think I'd like to hear, well, put it in the comments. And thank you very much for watching. Till the next video, happy trails.